now what we know we are working on is, look, I never ever like to go over something just once. So we're going to begin today. This video will be mostly reviewing stuff that we've been doing so far, and then we will work our way into equations and inequalities at a deeper level than we've been doing. So, our agenda, the homework review, the pregame stretch, and we've already done that. Now we're up to expressions and recap. So, expressions and equation recap, I should say. Okay? So, let's work on these equations. Suppose your weekly income is $3,500. You have the following expenses: cars, meals, movies, and tuition. Assign a variable to each expense. Please remember, stop and start. It helps me save memory, and YouTube save memory when I post these videos. So every time I say to do a question, pause the screen in front of you, do the question, and then start it back up again. Stop and start. Okay. So a good variable, C for car, meals, M or M sub 1. Movies, because I already used an M for meals, for movies I would prefer to use a V or M sub 2. And tuition is T. Now write an expression for your total weekly expenses. Okay, the expenses are the car plus the meals plus the movies plus the tuition. And you could write that as C plus M plus V plus T. Or you can write it as C plus M sub 1 plus M sub 2 plus T. Notice it is in alphabetical order, and I like that for reasons that will become more apparent as we go through algebra during the year and at increasingly difficult levels. Write an expression for how much money after expenses remains every week. Go ahead. Okay, that would be $3,500, the amount you started with, take away those expenses, namely C plus M plus V plus T. And it is extremely important that you put that in the parentheses, because you're taking the whole thing away. You're taking the group of expenses away, and parentheses are called grouping symbols. Okay. I don't know why these things flash. Something happened somewhere. Okay, next, your company is building a product to sell. Each unit requires the following parts: 9 pieces of wood, 24 bolts, 30 nuts, 5 springs. You sell U units. Write an expression for total number of pieces of wood needed, total number of nuts and bolts needed, total number of parts needed. Again, this flashing thing is going on. I don't know what's up with that. Oop. Okay, so I clicked one too many times. The answer to the first part is 9U, because you need 9 pieces of wood for every unit. So like if there were 3 units, it would be 9 times 3, which is 27. So 9U represents 9 times whatever the number of units is. Remember, that can vary, so that's why we use a variable. Okay, next up, total number of nuts and bolts needed. Okay, so there's 24 bolts and 30 nuts in each unit, so 24U plus 30U. Or you could just add them up and say, well, 24 U's and 30 U's make a total of 54 U's. And last but not least, the total number of parts needed. Go ahead. That's 9U for the pieces of wood, because each unit has 9 pieces of wood. 24U for the bolts. 30U for the nuts, and 5U for the springs. If you add that all up, you get 68U, right? 33, 63, 68U is correct. All right, next up. Explain the differences between a variable and an algebraic expression, and then we'll get into those development problems. You have 29 homes. Each will have casement double-hung windows. And go ahead. Do the whole thing, and then I'll give you the answers to the whole thing. Okay, so assuming again you're doing stop and start, that way we save a little bit of memory on YouTube. Variable is represented by a letter, for example, n. An expression combines numbers, variables, and operations, for example, 3n minus 15. What is the one thing that an expression never, ever, ever has? An equal sign. Very good. Okay, development plans to build 29 homes. Each home will have casement and double hung windows. Write an expression for the total number of casement windows that must be ordered for the entire development. Number 2, double hung windows for the entire development. Number 3, expression of numbers of for the total number of windows in a single house. And number 4, total number of windows for the entire development. So, casement windows is 29C. Remember, there's 29 homes. I don't know how many casements are in a home, but it's 29 times that number of windows, which can vary, so we give it a variable like C. Write an expression for the total number of double hungs, 29D. Number of windows in a single home. It's only got casements and double hungs, so C plus D. And then an expression for the total number of windows that must be ordered for the development. And what I really like about this question is there's 2 ways we could write the answer. The first way is to say, well, the total number of windows in the development is the sum of numbers 1 and 2. It's the total number of casements plus the total number of double hungs. So that's 29C plus 29D. The other way to look at it is, well, in a single house, you're going to have C plus D windows, casements plus double hung. That's all the windows in the house. And then there's 29 such single houses, so 29 times that grouping. Okay? All right. So you'll notice that everything we've done so far, it's so important to me to come back and cycle through these things. Not only have you not done math in 5 days, which means doing it today should have some review in it, but I like to cycle back and build, that and spiral to new curriculum. That's a great way to learn. All right, speaking of cycling back and building, let's have you do number 1 here. Go ahead. Okay, so number 1 says 3x plus 2y. If x is 7 and y is 4, I substitute them both in. That's where we're at here. And then order of operations says we multiply before we add. So 3 times 7 is 21. 2 times 4 is 8. Add them up, 29. Try number 2. Careful of that exponent there and how that relates to the order of operations. Go ahead. Okay, so next up, 4 times 5 squared minus 5 times 7. 5 squared is 25. 4 times 25 is 100. 5 times 7 is 35. Now I get to subtract. 100 minus 35 is 65. The big reveal in this question, if you will, is that you have to square the 5 before you multiply. Okay, so those are 2 evaluating expression problems. Chance to review those. Now, let's evaluate another expression, more of a killer question. Okay, 2 questions to do first. We'll do those now, and then we proceed forward with the question. What operation do you do first? Look that over. Now, you remember we talked about this, and there's a tendency among some students to say, oh, the first operation is the parentheses. No. Parentheses, it's not, because what you get there, parentheses is not an operation. However, you're doing what's inside the parentheses. So the operation you do first is subtraction. And then the second one is the exponent or exponentiation. Okay. There's a start. I substituted the numbers for you. Take it through to the end. Go ahead. Okay, so working it out, first thing I'm going to do is those operation inside the parentheses we spoke of. 4 minus -5 is 9. Now I do the exponent. 1 to the 99th is not 99. Inevitably, someone will get a little careless with that. 1 to the 99th is 1. And now I need to do my multiplication from left to right. 2 times 9 is 18. Then 2 times -2 is -4. Then adding left to right, that's going to be 29 minus 4, which is 25. Okay, another very important point that we spoke of the other day is a note about more than and less than. And the idea that when we see these phrases more than and less than, we want to remember waiting on the day when the first shall be last and the last shall be first, as Springsteen sang in The Ghost of Tom Joad, which he took from, it wasn't in the Sermon on the Mount by Jesus, but it was one of his teachings. So 7 more than a number is n plus 7, and 7 less than a number is n minus 7. Why? Because the last shall be first. So it says more than a number, the number shall be first. And the first 7 shall be last. Same on the second one, 7 less than a number. The last number, n, has to be first. 7 first shall be last. Okay, now let's just do a little bit of equation review. So when we see a linear equation like 4x plus 2 is 14, we should not think to ourselves, 4 times what number? Then add 2 is equal to 14. Now, let's be clear, that approach does work for the easy ones. But what about the tough guys? Now, I'm really good with fractions, decimals, off the top of my head, complex numbers, I can do them all. I can't do that, all right? There's no way. So I strongly believe that it's highly unlikely that you can look at that and get that correct too. So what we need is a strategy or an algorithm. It's kind of like, I've mentioned to you that I coach wrestling. Look, if you are a fantastic athlete, in great shape, feeling perfectly healthy, and then you're a senior in high school and some 9th grader comes in who's hasn't yet matured physically, and you're like a man, and you know basic wrestling, you could probably throw that kid around like a rag doll and beat him. But if you then go wrestle the state champ, you're going to get spanked unless you use proper technique. So that's what we want. We want proper technique. So like a detective, we need a strategy to develop this proper technique. We need a process. And exploring this process is what we spoke of the other day. Okay? And that is Detective Columbo. Peter Falk starred as him in the TV show years ago. Kind of a little bit of a wacky show like the old show Monk, if you can remember it. But Columbo, great detective. So let's be a little bit like Columbo. I'm going to do this first one and then turn you loose on the next two. So this is a basic two-stepper. These should be very simple for everybody. The first thing we look at, we want to undo not only whatever's happening to the x, but the order of operations. So the last thing that would happen is any addition or subtraction. It says -9, I do +9. Always make sure I do it to both sides of the equal sign. So on the left side, -9 and +9, they are inverses of each other. They wipe each other out. My teacher would have said they go die-die. I don't know how politically correct that is these days, but that's what I learned in high school. So that gives me 5x equals, and then on the other side, 36 plus 9 makes 45. 5x means 5 times x. So we need to do the opposite of multiply, which is divide, and that gives me x is equal to 9. Okay, you try the next one. Go ahead. In fact, let's make it the next two. Okay, so I'm going to add 3 to both sides. That gives me -9n or x. I told you I always make sloppy mistakes. I do apologize. This will be far from the last one. Is equal to 27. Divide by -9. X is equal to -3. Okay, on the next side, it says +5. We do -5. D over 4 is -7. Multiplying both sides by 4. D is -28. All right. All right, don't know why we're not going forward here, but we'll fix that right now. All right, you try these two. Go ahead, then I'll go over the correct answers to them. Okay, so you should have been doing stop and start. Let's keep going. First, these are on the same side, so we do the same operation. What do I mean by these? I mean the h's and then 23 plus 4. So 5h plus 4h is 9h, minus 18 is equal to 23 plus 4 is 27. Add 18 to both sides. 9h is equal to 45. Dividing by 9, h is equal to 5. Next one up on the other side, I have to distribute the 3 first. That gives me, remember over here, 3 times 2k is 6k, 3 times negative 5 is negative 15. And we always want to start with the smallest number of the variable. So typically, most often, we seem to start on the right, and we would do like minus 8k. But in this case, that would lead to negative k. So it's much easier to start with negative 6k. You just have to remember, danger, 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 that there's a negative in front of this 15. So when I subtract 6k from both sides, I get negative 15 equals 2k, because 8k minus 6k is 2k, plus 1. Don't forget about this with the negative in front of the 15. That's a very, very common mistake. Subtract 1 from both sides, or add negative 1, which is actually how I like to think about it in my head. 15 negatives and 1 more negative makes 16 negatives equals 2k, dividing by 2. K is negative 8. Okay. All right. So, I'm sitting here and I'm rolling my neck back and forth, stretching myself out, trying to get my back loose, because that's what we've been doing with our brains so far. With our brains, we're just trying to stretch things out. We're not hitting anything too hard. We're reviewing everything. This gets a little bit more involved. Each step of the way, we're offering a little more mental resistance. So let's try this one. Go ahead. Okay, here is your correct answer. Same side, same operation on both sides, because in this case, the 9x and the minus 2x is 7x. That is a combinable or grouping thing on the left side. And on the right side, you can't group x's together, but you can group the 1 and the 16 to get 17. Always start with the smallest number of x's, which in this case is a negative 5x, and the opposite is plus 5x. So I get 5 plus 12x is 17. I subtract 5 from both sides. 12x is 12. Dividing by 12, x is 1. Now keep in mind, the directions here say to also check. And for that, you take the solution, and you always put the solution in the original equation. Any equation, for example, this first line here where I wrote 5 plus 7x equals 17 minus 5x, after the first step is what we call a derived equation. And the derived equation could check and yet be wrong. And the reason for that is because you may have made a mistake between the question and the first step. So we want to make sure that we always check in the original question. And there's the work to show you that it checks. Let's try that again with this one. Go ahead. Okay. Again, I see same side, same operation here with the x's and also with the numbers on the right. So with the x's, 5 minus an x is 13 minus 2x. Now the smallest number of x's here is negative 2x. So I add 2x to both sides. That gives me 5 plus x is 13. And then I subtract 5 and I get x is 8. Now, this is the beauty of always beginning with the smallest number of each variable. The reason that's so beneficial is if you notice when we got to 5x plus 5 plus x equals 13, had I not done that, I would have gotten 5 equals 13 minus x. Then I would have subtracted 13 and I would have gotten negative 8 equals negative x. And then I would have to divide by negative 1 to get 8 equals x. So it's just a little more convoluted if you don't start by adding or subtracting the smallest number of the variable. Okay, next up is the check. And just as we said before, we always check in the original equation. We do not check in any derived equations. Okay? All right, so next up is an example. I don't know why this word examples is underneath there, but it is, and hopefully you can ignore it. There's a relationship between the number of words in a child's vocabulary and after the age of A in months for ages between 15 and 50 months, inclusive. This relationship can be modeled by B plus 900 equals 60A. Since they gave you the equation, you don't really have to think about it too much. Use the formula to find the number of words in a child's vocabulary at the age of 50 months. So I just plug in a 50 for A, okay? Vocabulary number of words, V, plus 900 equals 60 times A. 60 times A is 3,000, right? 60 times 50. Subtracting 900 from both sides, they just write it horizontally. V, it's down here in orange, equals 2,100 words. Okay, I know we did that exact slide the other day. We had gotten these slides from the book company, and it's a little difficult to edit these slides, so I just went with reviewing it one more time. Okay, let's solve this one here. Remember, every time you look at one of these, you're asking yourself, is this the same side or an opposite side situation? Go ahead. Okay, as I look here, I see the variables are on opposite sides and the numbers, so this is an opposite side, opposite operation. I want to undo the minus 5x. I do that with plus 5x. So I get 7x minus 15 is negative 1. Now it looks like a standard two-stepper, so it's like cruise control here. Add 15 to both sides. 7x is 14. Dividing by 7, and x is 2. Ding, 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 ding. We are in great shape. Any questions? Okay. Next up, what is the procedure for solving linear equations? Let's review this as the last piece of video 2. Is it a same side or an opposite side situation? If it's the same side, you do the same operation. Opposite side, opposite operation. You want to work toward a standard two-stepper. Once you get to a standard two-stepper, cruise control. Isolate the variable and solve. At the end of the day, that's the important thing to do. And then number 4, check the proposed solution in the original equation. So, and that's if they ask you to check. If not, I like to do a quick mental check to see what's going. Now, here is, oh, you know what? I'll start this on the next video. But for now, this is good.